Understanding and meaning are intangible concepts. Let's see what Ellie from Brown University has to say about these ideas in the context of AI.
There's a lot of chatter about AI right now. We're not used to consuming language that wasn't produced by a human. Suddenly you're talking to something that feels very much like there's a human on the other side. These large language models can give you goosebumps.
AI is definitely a hot button subject right now, and it's hard to distinguish if you're actually talking to an AI or a human, and it's only going to get harder.
This question of whether language models can actually have meaning, learn meaning, encode meaning is probably one of the most fundamental or most debated questions right now. There's this crazy opportunity to learn a ton about AI and about humans. What does it mean to be intelligent? What does it mean to think and to reason? How do you know that a system is behaving intelligently?
AI is a mirror for humanity. Since we're feeding it all the data and it's predicting based on what we input, AI is just a mirror to what we put into it. So ultimately, it's reflecting back the collective conscious to us.
We've been taking these generative AI systems and trying to understand really how they work under the hood. They slurp up an enormous amount of data, like the entire internet, but all they're actually doing at a very basic level is literally to just predict the next word in a sentence. So they're just learning a very good probability distribution over what those next words look like. What is going on when you ask a language model question and it gives you an answer? There's some process that connected that input to the output. We're trying to figure out what that process is.
This is the black box. We know the answer, we know the question, but we don't know the process in between that led AI to the answer.
And then we've been doing a lot of work with cognitive science, with neuroscience, to try to ask similar questions about humans and then just say how similar are these two processes. The relationship between AI and neuroscience, it's always been there because both of them are about intelligence and the nature of intelligence. The kind of similarity has become even stronger in recent years because the nature of the artificial intelligence models we have right now are things that, to a large extent, we stumbled upon.
So while we try to figure out this black box problem that the AI has, we're also studying our own consciousness. We're almost building a consciousness outside of ourselves to study consciousness. It's just the brain trying to learn what the brain does. We don't know exactly how we came to thoughts, so we're trying to learn through external means about how our internal happens.
They are not carefully engineered systems the way AI systems of the 1980s and 90s were. We're just like, oops, it's now speaking language as well as humans. And so now we're very much in the position that neuroscientists are, which is, I have this system, it's a complicated system, it has a behavior, and I need to come up with a theory that explains the behavior and predicts the behavior.
Pretty neat, if you ask me.
There's this kind of feeling that because they've only had access to text and not to the actual world, large language models can't really encode meaning because meaning is about what's in the actual world. These large language models, they're neural networks, and they have billions and billions of individual numbers that are playing some role. And so we have to figure out how to sift through those and pull out pieces of them. So when I use a word like apple, there's this huge web of stuff I know about apples. A crisp fall afternoon and walking out in the orchard, going apple picking with my kids, making pies. There's obviously a huge part of the meaning of a word that comes from sensory experience, but then there's a huge part that doesn't.
Which is a difficult thing for a computer to understand because it doesn't have sensory experiences. It can only interpolate based on the data that we give it. And sometimes it's hard for us to even describe sensory experiences.
How much could a language model that has really good access to a lot of data generated by humans who did have access to the real world, can it proxy or even get the real thing just from that text?
Actually, it's hard for us to describe sensory experiences most of the time. Some things in life are just ineffable.
How to actually look for these concepts or this meaning within large language models, these are really, really big questions. We don't have the answers to them, and we should be open-minded in trying to study them. I don't think these systems are human level, but I think there's things that are happening inside them that are non-trivial. within my lab, within a single project, we will have results that simultaneously suggest that the model is actually quite clever and represents things in a way that we would call systematic and compositional and human-like in a certain way. And at the same time, is just doing something wild that just seems simply dumb, right? You're just like, this model is so dumb. And those things can kind of both be true.
We're in the infant stage of this technology, and that's why studying it and trying to learn ourselves are so important, both at the same time. Because in order to learn ourselves better, we need to start at the basics, exactly what AI is starting at. Studying ourselves and AI can happen simultaneously, and it is. Life is full of paradox, and there's power in embracing it. If you like this video, hit those like and subscribe buttons, and I'll see you next time.